Today I'm going to talk about various types of MOSFET and BJT. So let's start. Until last class, we learned about the various types of MOSFET and the characteristic of MOSFET. However, we just learned about the long channel effect. So if we make a smaller transistor based on MOSFET, the short channel effect will be happened. So I will talk about the short channel effect briefly. Nowadays, we need a smaller transistor than before because we should make a smaller smartphone and thinner television and so on. So we should make a smaller transistor than before. So if we make when we make a smaller transistor, that the short channel effect will be happen because the source and gate and drain will be the distance will be very smaller than before. So if electron can make a tunneling to each side, so it makes a leakage current. And also because of short channel distance, the energy band diagram will be changed and the barrier will be lower than before, so electron will flow to other side more easily. So it happens the leakage current that we don't expect before. So we should prevent those leakage currents because we should make higher efficiency. So leakage current will down the efficiency. So we should prevent that leakage current. So there are many solutions about short channel effect. I think there are no exact solution. However, we should make a difference of depletion region. So if the depletion region overlapped, the leakage current will be more higher. The current leakage more than before. So we can make LDD or pocket implant to lower the depletion region, make smaller depletion region overlap. So it can be one of solutions. So yes, those solutions will prevent the short channel effect and the leakage current. So today we will talk about the other material about MOSFET. So we will talk about the 3-5 material first. Before we use silicon mostly, however, silicon has a limit, so we should discover something else material to make more higher efficiency. So this 3-5 material is one of the solution of that curiosity, but actually I heard this 3-5 material is hard to use in the real world. So it cannot use mostly, but those research is always always doing now until now. So let's talk about this 3-5 material. 3-5 material is look like this way, and the biggest characteristic of 3-5 material is this ID current graph. Actually, we want current flow like this red line, because if the ID current flow poorly, we cannot control the switch on of the transistor. So hopefully we want to make this red line current flow. However, 3-5 material current flow like this purple line. This makes leakage current and lose the power. So it is not so good transistor for engineer. However, it has, if we don't care about the off current, the left side of current, if we just focus on the on current, this 3-5 material will be the good material for engineer, because it has a big current flow. So if the engineer wants the high frequency operation, some engineer can use the 3-5 material. However, if we make a cell phone or something smaller things, this 3-5 material is not good to use. So yes, until now we always search about the characteristic of 3-5 model material, and yes, we studied to how use this most efficiently. Yes. And then this is the JFET. It is another type of MOSFET. Actually, JFET flows the current based on the depletion region. So if we control the depletion region, that the depletion region make the path of current. So if we make more bigger depletion region, the current cannot flow much. However, if we make smaller depletion than before, the current will flow more higher than before. So JFET use the depletion region to flow current. And then let's talk about the BJT. BJT is, I heard that BJT are not used much anymore, but we should know the basic theory of BJT, because it used popularly more 20 years ago. So yes, BJT has the base, emitter, and collector. So emitter works to emit the electrons, and base make the drift or diffusion to collector, and collector works to collect the electrons. So it is the basic work operation of BJT. And then electron moves emitter to collector, so current flow collector to emitter. We should know about that current flow path. And then yes, this is the active mode of BJT. A BJT works like this, and then the voltage, collector and emitter voltage is equal to collector and base voltage plus base and emitter voltage. It is the basic theory of the voltage division of BJT, and current will flow like same way. So emitter current is equal to collector current and base and plus base current, because emitter emits the electrons to base and collector, so it is that current will be the sum of base and collector's current. And there are four types of BJT mode. So first, active mode and saturation mode. Fourth, active mode, cutoff mode. So actually we define the three types of mode: active, cutoff, and saturation. So we should change the type of mode and use the BJT more efficiently. And this is the ID graph of BJT. A BJT current flow like this. So this line is the voltage saturation line. So yes, we use the voltage saturation to flow the current. And this is the active region. So we can control the mode like active or saturation to control the current of BJT. So we should know the characteristic of current flow, and we can control those things. This is the common emitter. This is the in the common emitter, Miller effect is happened. So this Miller effect influence the bandwidth. So if the Miller effect happened, because of the Miller effect, the bandwidth has a limit. So we should solve the Miller effect problems. So this is common base is the solution of Miller effect, and because of this we can control the base bandwidth and then current flow too. In the current gain, there are three types of how to get more good current gain. Injection efficiency, collection efficiency, and transport efficiency. So yes, injection efficiency means if we heavily doped on the base, that injection efficiency will be higher than before, and then the current gain will be better than before. And this transport efficiency means if we make more thinner base than before, that current flow will be higher. So if we make thinner or heavily doped, that current will flow differently. And in this situation, band gap narrowing also can happen. So we should solve this band gap narrowing problem. So we should dope the base gradiently. So if we dope the base gradiently, the band gap narrowing will be solved, because this energy band diagram will be changed than before. So actually, if we didn't do any doped, the current flow will be linear. So it means we cannot control the on-off easily. However, if we dope the base gradiently, the current graph will be changed like, yes, like not linear. So we can control the on-off very easily than before. So we should dope the base gradually is needed. So today we talked about the band gap narrowing and yes, met various types of MOSFET and BJT characteristics. So thank you for watching my video. Bye.